Hello, amazing students. Today we're going to be going over a few things that are going to be on our test. Of course, we have scientific notation, operations with scientific notation, like multiplication and division, and we also have exponents. So we're going to be reviewing everything. Yes, so I hope you had a great head start on this already. We're going to check our work, but first I have a little activity for you, okay? So this activity is this. Of course, write your name. What a great activity, right? So write your name first and which period you're in. Now, which period did I write down? I wrote X period, right? This is typically a degree symbol, like first period, first degree, or third period, etc. But what if this was actually a number? What if it was 0? Do you remember the rule for x to the 0 power? Yes, anything to the 0 power is 1. Keep that in mind. So technically, if you write x period, or 1 period, or even just 3 period, what is 3 to the 0 power? A 1. So kind of a little bit of a trick there. Let's begin. All right, so scientific notation for the a value, which is just the number that is being multiplied. We're going to have some crazy numbers today, I'm telling you. But for this number always needs to be a number between 1 and 10. They even say that it could be just the number 1. For example, 1 billion, however many zeros that has, is written as 1 times 10 to the power of how many zeros it has. Kind of amazing. But usually, scientific notation has to be between 1 and 10. Not less and not more than 10. Okay. And then, of course, the integer, which is just a positive number. It's going to be positive if it's a big number. And it's going to be negative if it's a decimal. For example, what's the width of a tiny hair? If you take a look at a hair, what's the width of that hair? The width of the hair is microscopic. So anything with a decimal needs to be written with a negative number. And anything with a lot of zeros and a lot of just basically a big number, for example, how far are we from Mars? Oh, very far. That's going to be a positive exponent. Okay, so microscopic, negative. Gigantic would be positive exponents. Let's start with the first one. So, of course, this is just like our quiz or tests or things that you see on your exams. SBAC, all the fun stuff, right? Is we need this decimal to not be over here. We need the decimal to be over here. So, how many decimal places to the right would I need to move? 1, 2, 3, 4, 5. Since that is to the right, we need to write our answer as 5.63. I hope you got this right. Times 10 to the power of 1, 2. How many was it again? 1, 2, 3, 4, 5. Okay, but it must be written as, yes, what's my mistake? Yeah, microscopic numbers need to be negative because that just means I didn't really multiply by 10 5 times. I actually divided by 10 5 times. Okay, so just kind of a little bit of a heads up. If I take out my calculator and I do 5.63 and I divide that by 10 once, twice, 3 times, 4 times, and 5 times, I'm going to get 0.0000563, which if you see this, it's the exact same number we started with. Kind of fascinating, right? Yeah. Number 1B. Number 1B is our favorite. It's a bunch of zeros. Now, I love the commas because they tell me it's 3, 6, 9, and 10. It's 10. Otherwise, if you like to draw all those little curves, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's going to take us 10 decimal places to get to 4.37. So for our answer here, yes, I hope you got it. 4.37 times 10 to the 10th power. Now, please do not make the mistake of writing 4.37 to the 10th power, because 4.37 to the 10th power, if you keep multiplying by 10, oh wait, no, what does 4.37 to the 10th power even mean? 4.37 to the 10th power means you're going to multiply 4.37 by itself 10 times, which is not even close to what our answer here is. You're going to see all these random numbers show up, right? Because if I multiply by 10, that gives me the same numbers. But if I multiply by itself, it gives me completely different numbers. So always say times 10 to the number of times that it's multiplied by 10, which is 10 places for this one. Okay, now if that doesn't make sense yet, we still have two examples here. So letter C, here we go, letter C. The decimal always starts here. If there is no decimal, it's at the very end. And we're going to need to move how many decimal places to the left? 1, 2, 3. So we're going to write down 3.73. Yeah, you could write a 0 if you want to, but we usually get rid of them. Times 10 to the power of 3, because I moved over 3 decimal places. All right, I hope you got that one right. That is the correct answer. Let's move on to the next one. Now, as always, if I make a mistake and you catch a mistake, that just means I'm a mathematician and I make mistakes. I'm human. So if you catch any mistakes, please let me know and we'll go ahead and point that out. All right, number 1D. This is going to be a microscopic number, so we know it needs to be a negative exponent. Where does the exponent need to, where does the decimal need to be? It needs to be right here. Oh, whoa. No, not 91. It needs to be 9.1. So that's going to take us moving 1, 2, 3 decimal places to the right. So that's 10 since it's to the right. Let me write it correctly. 9.1 times 10 to the power of negative 3. That means if you're like, Mr. Maynard, you showed a calculator stuff. What were you doing? Well, you take 9.1 and you divide by 10 once, twice, and 3 times, and you'll get the number. Yeah, you'll remember that negative exponents is actually division by the positive exponent. We'll get to that though. All right, next up is number 2. This is going to be something you'll see on your test as well. Now, how do we do multiplication of 2 different things? Let me show you, and I'm going to try to make it interesting as well because it's going to be a lot of repetition. So what you do is you take the 2 numbers and you multiply them. So what you have to do is you're going to do this by hand if you don't have a calculator on your test, which most of the time you don't get a calculator, right? No calculator, right? Yep, no calculator. So you're going to take those 2 numbers and you're going to multiply them. Why do I multiply? It's because this is a multiplication problem. So I'm going to take those 2 numbers and I'm going to multiply them. 1.08 times 93. Oh, 9.3. Okay, same thing. We're going to get what? Yeah, I'm going to do this by hand. So give me some moments. Just like you're going to take your time on your test. I'm going to do the multiplication problem here. 8 times 3, 24. Carry the 2. 3 times 0, 0. Add the 2. 3 times 1, easy. Add a 0. 9 times 8, 72. Carry the 7. 9 times 0, 0. Add the 7. And finally 9 times 1. 9 times 1 is just 9. Add. Adding all those numbers, I'm going to get 10, 4, 4. That means 1 times 9 is approximately 10. and that's going to give me 10.44. So 9.3 times 1.08, let me write it correctly, is 10.44. Okay, that's great news. No, it's bad news. Why is it bad news? Is that a number between 1 and 10? Nope. Yikes. Okay. That means I have a little bit of extra work on my hand. Let me put this to the side. My next step is going to be to multiply the tens. 10 to the negative third power times 10 to the negative third power. Now I wish I can just say, oh, that crosses this off. Maybe not. It might, but it might not. What's the rule for exponents when you multiply? When you multiply powers of the same base, you gotta add. Let me write that down. For blue, we multiply the two numbers. For pink, we gotta add -3 plus -3. -3 plus -3. It's just the exponents. What would that give you? Not the final answer. I keep saying final answer, but I know the next step is not the final answer. We have 10.44 times 10 to the power of -6. Okay, is that called proper form? No, it's not proper scientific notation. So, do you remember how to change it to scientific notation? If you don't remember, let me show you. Where does the decimal need to be? It needs to be right there. I'll zoom in super close. Okay, not that too close. Not that close. Too close. The decimal needs to be right there. Where was it? It was over there. So I'm going to point the arrow to where it was. Now, on the number line. On the what? The number line. Yes. To the right. What does that mean? Left or right? Right means subtract or add. Right means add. So I'm going to add 1, and I'm going to add 1 over here. That just means the 10 place just moved from the tens place to the ones place. So I'm going to add a 1. Now, of course, you might be like, Mr. Maynard, I need more examples. This is not enough. I don't understand it. We have plenty. How many? Yes, we have plenty of examples to go over today. Don't worry. Final answer, 1.044 times 10 to whatever this is, -6 plus 1, -6 plus 1. Don't make the mistake of saying it's -7. No, if you owe me $6 but you pay me back 1, you happen to owe me only $5. And this would be the answer. Amazing if you got that one right. That's a very tough question. Let's move on to the second one. Now, hopefully the second one's a little easier. Maybe not. Here's why. If I multiply those two numbers, will it be a number between 1 and 10? Doubt it. 4 times 2 is 8. 4 times 0.32 is a lot. If I'm lucky, it'll be a number between 1 and 10. Is it? Let's see. So I'm going to use a calculator. To save you time, I'm going to use calculator, but of course on your test, be prepared to do this by hand, okay? For now, allow me to use a calculator. What I need to do is I need to multiply 2.32 times 4. 2.32 times 4 happens to be... Oh, we lucked out. Oh, man, did we luck out. 2.32 times 4 happens to be 9.28. You're like, Mr. Maynard, what do you mean you lucked out? We can't use calculators. No, it's not that. You can do this by hand, no problem. Just do 2.32 times 4. Multiply. You'll get the answer. When I say good news, is this guy is already proper. proper means it's a number between 1 and 10. Is that a number between 1 and 10? Whew, I thought it wasn't. But it is. Yes, it is a number between 1 and 10. Now, all we need to do is do the product rule. Product rule means I'm going to add -6 plus -5. Now, what does -6 plus -5 mean? -6 plus -5 means I'm going to do -6 minus 5. Final answer. -11th power. Hey, good news. We can actually make sense of what are we even doing. Let me show you. Let me show you a little bit of a lesson here. Do you agree that this is a small number? Yeah, it's a pretty small number. It's got, it's pretty small. Now, do you agree that this one is a pretty small number? Yeah, that's a pretty small number. Now, what happens if you multiply a small number by a small number? Yes, if you multiply a small number by a small number, you get a really small number. Now, do you agree that this is a really small number? Yes, that is a much smaller number. That's the reason why we have to add the exponents, is because small times small is really small. Now, if you don't believe me, take out a calculator. What's 0.00002 or 0.00002 times 0.0000357? Just another small number. Yeah, you get an extremely small number. That's why this makes sense. Let's move on. I hoped it made sense. Here we go. I'm going to go ahead and multiply these two numbers, 6 times 9.91. 6 times 9.91, to save time, I'm going to use a calculator. 6 times 9.91 gives me 59.46, right? Yep. If you did that already, good job. 59.46. Now the exponents. I have to add 3 and 0. Ooh, easy. Why is this easy? 3 plus 0. 3 plus 0 is kind of easy. Let me zoom out for a bit. Now, I'm going to get my answer. It's not the final answer, of 59.46 times 10 to the power of 3. Is that proper? Nope. Decimal gotta be here. Okay, let me slow down for a bit. The decimal has to be here. How do I go back to where I was? I have to move to the right. This is a wonderful trick. I wish I knew this when I was in middle school. I have to move to the right, which means I'm going to add 1. So final answer, 5.946. Move the decimal over to the left or right, and you're going to get times 10 to the power of 4. It was 3, now it's a 4, because it moved over. Okay, next up. We got another one that's difficult. That's okay. Difficult doesn't scare us. We got this. So I'm going to multiply those two numbers. 7.1 times 6.7. 47.57. I got this. You got this as well. And I'm going to add the exponents. So I'm going to add the exponents just like I did all the other ones. It's just patterns. Math is patterns. So what I get is 10 to the power of -5 plus -6. Now these are all very, very similar problems, but hopefully it's helping us to prepare for our quiz. Okay, next step. 47.57 times 10. Yeah, what's -5 minus 6? -5 minus 6 is -11. A small number times a small number is a really small number. Really small number. And that's my answer. Whoa, that's not my answer. Why is it not my answer? Yes, is this proper? Is that a number between 1 and 10? No, good job. I know you got this. Now, the decimal needs to be here. To go back to where I was, I would need to add 1 decimal place. Now, don't make the mistake of adding incorrectly. The correct answer here is negative 11 plus 1 brings you to negative 10. Did I make any mistakes? Double check. Always check your work. I think we're good. Yes. All right, that brings us, go ahead and flip your paper if you're ready. We're going to go to division. We just did 4 multiplication problems for scientific notation. Our next step is division. So another way to say division is called the quotient rule. Do you remember the quotient rule for exponents? If you don't remember it, let's take good notes. If it's the quotient rule, which is basically a fraction, I'll give you an easy example. All you would need to do is simply subtract. 7 minus 4. 7 minus 4? Yeah, if you subtract, you'll get x cubed. But that's an easy example. Let's go to the hard stuff. The hard stuff is what I see right here. Now, I'm going to give you a heads up. These numbers are not going to be pretty, but we can do this. Step 1, division. This is the division problem, so I'm going to divide those 2 numbers. Now, your test is going to have much easier numbers than this. Let's see what 9 divided by 9.24 is. Is that correct? 9 divided by 9.24? Yes. 9 divided by 9.24 gives you this horrible number. Why is it horrible? It's because, do you want to write every single digit on your paper? Hey, if you're feeling awesome, you do have plenty of space on your paper. Yes, you could write all those numbers. But I personally am going to round it. Okay? Is that okay with you? Let's see if I can memorize this phone number. 9740259. 97402. Let's do 6. 974026 to round. 974026. 974026. Did I memorize it correctly? 974026. Double check. Yes, on your test, easier numbers. But this one, I'll just write several digits. Okay, now what really matters is the quotient rule. The quotient rule says I have to subtract these 2 values. Now, it's not going to be super straightforward sometimes. We have negatives. Negatives are not always the easiest. But if I follow the quotient rule and subtract correctly, I'll get the right answer. Now, the rule, it says to do negative 5 minus, yeah, keyword minus, negative 6. Since it's 2 negatives, what is that? This actually becomes kind of an easier problem, slightly easier. Look at that happy face right there. Oh, wow, so happy. Why is it a happy face? Because 2 negatives is a... Yeah, this guy is feeling positive. So negative is a positive. Let me make a little note of that. 2 negatives makes a... Look at that happy face. 2 negatives makes a positive. Okay, so our next step is approximately... I'm going to write this down again. 974026 times 10 to the power of 1. Ooh, weirdo. This is a weirdo question. It's a rare one. We have 10 to the first power. What does that mean? Yeah, negative 5 plus 6 is 1. But what does that mean? That means you can leave your answer like this. Some people say, hey, for scientific notation, you got to leave your answer like this. But realistically, The answer is 0.974026 times just the number 10. Oh, I made a mistake. I made a massive mistake. Did anybody catch that mistake? What's my mistake? I caught it. Did you catch my mistake? The mistake is what? Is this, what do you call it? Is that proper? Is that a proper number? No, to make it proper, the decimal needs to be here. How do I make it go there? The trick is to go back to where it was on the number line. This is a -1. If you're going left, it's -1. So what that gives you is 9.74026 times 10 to the power of even weirder. This is way more weird. 10 to the power of 0. Now, some people believe that this is your answer, while others say it is totally fine to write this as just 9.74026. Here's why. What is 10 to the 0 power? 10 to the 0 power is just 1. So therefore, 9.74026, or this huge number, is my answer. Now, I'm okay with this one. I like the top one. Why? Because it has times 10. Usually scientific notation says times 10, but a lot of other teachers and people and mathematicians will say, just write your number if it's a 0 power. Okay? Kind of strange, but if you want to talk more about that, we could talk more about that. For right now, let's move on to the next question. Now, question number 2. Step 1, divide both numbers. If I divide 8.9 divided by 8.4, what does that give me? Oh, again, it's another phone number. It's an extremely long phone number. It's long distance. 1.059523.8. How many do you want to memorize? 1.059523.8. I'm going to round this number right here to a 4. 1.059524. 1.059524. Let me memorize that. I think I got it. 1.09. Oh, I already forgot. 524. 1.059524. 1.059524. Did I do that correctly? Yes, I did. Let's go. Okay, that's still approximate. Okay. Next up is, what do I do for the division, the quotient rule? Yes, the quotient rule says to subtract. If I subtract both numbers, I'll get 10 to the 6 minus 6. Another very strange question. Here's why. This number is proper, very proper. The second number is weird. 1.059524 times 10 to the 0 power. You can leave it like that. Otherwise, as you already know, you can rewrite this as just 1.059524. Since 10 to the 0 power is just a 1. Okay? Now, I'm going to give you a moment. You can definitely pause the video here, and I want to see if you can do the third example. Go ahead and try the third example on your own. Step 1, divide 4 divided by 3.63. And bad news, I think it's going to be a long distance number again. Step 2, subtract because of the quotient rule. Pausing in 3, 2, 1. All right, here we go. Let's go over the answer here. 4 divided by 3.63 gave us a great proper number, 1.10193. And if you added the exponents, yes. 4 minus negative 4. 4 minus negative gives us a happy face. Look at that guy, how happy he is. So happy. And then 4 plus 4 will give us 8, and that is our final answer. Okay, I'm going to move on to our Chapter 8 review. Let's move on. I'm going to do it super slowly. I'm going to move down super slowly. Make sure you have this in your notes. We're going to move on to the Chapter 8 review. All right, Chapter 8 review. I hope you had a chance to get a head start on it. If you haven't, this is a great time to pause to give you a few minutes to try some of these problems on your own. Okay, Chapter 8 review. Remember, this is a review for what is on our test. We're looking at operations of scientific notation. We're looking at exponents. And a little bit of a heads up, this stuff is coming up on our, either on our test or some sort of future test. So we're going to add that onto it. So let's check number 1. Number 1 is a negative exponent because it's a decimal, small number. Number 2 is a positive exponent since it's a really big number. Now it's been moved over 6 decimal places. You can see one was moved over 6 to the left and one was over 6 to the right, or vice versa, and that means one is negative and one's positive. Now let's go ahead and take a look at the next one here, number 3 and number 4. Number 3 and number 4 are not written in, what's the word? Proper form. So what would be the correct exponent? This is very good practice for our test. So put the decimal where you need it to be. Move it to where it was. How many decimal places is that? It is 2 to the right. That means I'm going to add 2, and that means my final answer is simply whatever 4 plus 2 is. Now, what is 4 plus 2? Easiest question of the day, right? 4 plus 2 will give us 6, and that's the correct answer. Yes, that's the correct answer. Number 4. Let's see if you were able to do this one. This one's a weird one, but put the decimal where you want it to be. Go back to where you were for the decimal place, and it is 2 to the left. Now, 2 to the left, is that addition or is that subtraction? Yeah, if I do 2 to the left, I need to subtract, because on the number line, left means subtract. So, final answer, 1.57 times 10 to the power of, correct answer would have been -6. Okay. Now for number 5 and 6, our goal here is to, what does it say? It says to simplify and write it in proper form. Very good practice for our test here. So for number 5, what did you get when you divided 3 by 8? 3 divided by 8 as a decimal. I know this one. 3 divided by 8 is 0.375. Should we double check that? Sure. 3 divided by 8. 375, let's go. Okay. Now, the rule for the exponents of division is the quotient rule. I must subtract. So if I do -2 minus -1, we get a happy face. Yeah, 2 negatives makes a positive person. So we have 0.375 times 10 to the -2 plus 1. -2 plus 1 is -1. Is it proper? It's not proper. So we need to move the decimal over. I'm going to add it over here. I need to move to where I was. That is left, so I'm going to subtract 1 and do the same on my exponent. Final answer should have been, thank you for hanging in here, by the way, 3.75 times 10. Thank you for writing this down. 10 to the negative 2. Now, do you have any questions? This is a moment where you can ask questions. Hopefully, you can pause the video. Hopefully, your teacher's by you, or a tutor, or a friend that can help. Any questions so far on this page? Okay. Number 6. So for number 6, did you divide 4.1 by 1.28? Let's see if you did that correctly. 4.1 divided by, what was it? 4.1 divided by 1.28. We get 3.203. This is great news. Great news. We get, let's write the whole thing. We got 3.203125. 3.203125. Did I memorize that correctly? 3.203125. Let's go. I got it. And now that is times 10 to the power of 4 minus negative 5. What is 4 minus negative 5? 2 negatives makes a... Yeah, it's all repetition, guys. You got this. Good job. 4 plus 5. Final answer. And I am definitely getting this one correct. Hopefully no mistakes. I know it's not a mistake because this is called proper. Proper scientific notation. 4 plus 5. 9. If you got that right, good job. Let's keep going. We're hanging in there. We're almost done. Number 7. Multiply these two numbers. Unlucky. We get 11.016. And I'm going to do the, what's the rule for multiplication? It's called the product rule. I need to add 4 plus negative 12. It's multiplication, so I need to add the exponents. What that gives me is 11.016 times 10 to the power of whatever 4 minus 12. 4 minus 12 is negative 8. Is that correct? Yeah, 4 minus 12 would mean you owe me 8. Okay, proper form. This is not proper form. So I'm going to move the decimal to where it needs to be. Draw an arrow to where it was. Does that add 1 or subtract 1? Yeah, on the number line, it's to the right. If you said add 1, that is correct. We get 1.10, let me write this correctly, 1.1016 times 10 to the, don't make a mistake, negative 8 plus 1 is negative 7. And that would be the correct answer. Let's move on. Hopefully this one gives us, oh no, it's not an easy one. But it's easy when you've practiced it. 5.98 times 2.1. Thank you so much for practicing with me today. Oh, wrote that wrong. 12.558. Thank you for writing that down. Or checking your work. Now, what's the rule for multiplication? You gotta add negative 12 plus 27. Negative 12 plus 27 is the same as 27 minus 12. We're gonna get 27 minus 12 happens to be 15. Is that correct? Yes. Okay. All done. Nope, not all done. Needs to be proper. I'm gonna move the decimal here. That means I have to add 1. And if you got this one correct, I applaud you. Let me literally applaud you. Good job, guys. All right, 12. Oh, I wrote that wrong again. 1.2558 times 10 to the 16th power. I applaud you if you got that one right. Let's move on. Flip your paper. This one says exponents. No negative exponents. Do we like negatives? Nope. No negative exponents. So if you ever get an exponent that is negative, you're going to need to fix it. Here we go. So I'm really glad we're getting the chance to talk about number 9 because it was very similar to our test. Please do not do the quotient rule for this guy. When I say this guy, I mean this. 12 divided by 3. What is 12 divided by 3? Is it 8? Is it 9? No, what is 12 divided by 3? 12 divided by 3 doesn't mean subtract. You need to simplify. 12 divided by 3 is 4. Okay, I'm going to use a little bit of color here now. Let's practice this. We've got a lot of practice in here. It's going to be, for this guy, you're going to do the quotient rule of 7 minus 9. Careful with the double negative here. We have y to the negative 8 minus negative 5. And can you do this work on the side? Yes, you can. I'll do that for the next problem. 9 minus 14. 9 minus 14. Okay. What does that give me? 4. Yeah, 7 minus 9 is negative 2. Negative 8 plus 5. Yep, 2 negatives makes a positive. Negative 8 plus 5 is negative 3. And 9 minus 14 is negative 5. Okay. Good news, we're almost done. Bad news, you can't have any negative exponents. So there is a thing called the negative exponent rule, which means if you have a negative, you're going to move it to the denominator. There's a catch, though. If the negative is in the denominator, you're going to move it to the numerator. Basically, just do the inverse. The what? The inverse, meaning if it's in the topinator, move it to the bottominator. If it's in the bottominator, move it to the topinator. Or if you want to say it properly, proper, the numerator and the denominator. Denominator. We have, it's going to become positive, so we have x squared, y cubed, and what do you think the green one's going to be? A 4? Nah. The negative 5 becomes a positive 5. So, final answer looks like this. Study it. Study it. Let's move on. All right, number 10 is going to be the product rule. So we're going to need to do a little bit of multiplication here. 20 times 5, I'm going to start with 25. 20 times 5. 20 times 5 is 100. This time I'm going to do the work on the side, okay? So I'm going to do 14 plus negative 3. Product rule means to add. So 14 plus negative 3 is 11. So we get x to the 11th. For the y value, it's going to be 4 plus 9. I can do that on the side here. 4 plus 9 is 13. And our least favorite is these negatives, right? So for the negative here, we have negative 7 plus 2. Negative 7 plus 2 is negative 5. So for the z value, we have negative 5. Can we have negative exponents? No, no negative exponents. So we're going to move that to the bottominator. Final answer, 100. X to the 11th, which is already positive. We're good. We're chilling. 13th is already positive. We're chilling. But the negative means I need to write it in the denominator, the opposite part. So it's in the denominator as a positive 5 if we switched it. I'll use a little color coding here so you know that these numbers switched because they used to be negative. Now, if you're like, Mr. Maynard, I don't know why they switched. Well, what's the opposite of multiplication? Division. Yeah. What's the opposite of a negative exponent? A positive exponent. So the rule there is that you have to switch it. Okay, let's move on to number 11. Number 11 is one of the easiest questions on this page. Does it look like the easiest? No. But let us begin with the easiest part. Now let's start with this guy. Everybody knows what this is. Anything to the power of 0 is 0. No. Anything to the power of 0 is 1. That means we have an easier problem. I'm going to just rewrite this as that times 1. Now you know the 1 does nothing. So what do we do now? I'm missing something. What am I missing? Yeah, I'm missing the third power. Now this thing is going to be a power to a power, so I'm going to do my trick. My trick is when I see parentheses like this, I'm going to do something called the distributive property. I'm going to actually distribute. It's not really called the distributive property here, but I'm going to make sure that that 3 applies to every single term. So I'm going to get 4 to the third power, x to the 6 times 3 power, y to the 3 times 3 power, and z to the negative 8 times 3 power. Now, hey, do I need to show this work? No. Let's fix it. What's 6 times 3? 6 times 3 is 18. 3 times 3 is 9. And negative 8 times 3 is negative 24. Great news. Crazy problem became easier. Bad news. We're not done. No negative exponents means we have to switch it to the denominator. Let me write this down this time. It's going to become denominator as a positive, so final answer is 4 cubed, x to the 18th, y to the 9th, all over z to the positive 24th power. I see some smiles, virtual smiles. I know a lot of people said, I got that right. What? How did I do that? Now, there are some people on YouTube that are, if they're watching right now, they're saying, Mr. Maynard, your videos, they're good. They're kind of good. But my teacher at this other school says I can't leave it as 4 to the third power. I have to simplify that. So, you're right. You could simplify it, but for this test, you can leave it as an exponent. Do you know what 4 to the third power is? Yeah, technically you could write 4 to the third power as 4 times 4 times 4. 4 times 4 times 4 happens to be 64. You're like, what do you mean 64? Well, 4 times 4 is 16. 16 times 4 is 64. So technically you could write 64. Do you have to? No. But if your teacher says to, yes. All right, number 12. This is the last problem that I'm going to go over fully for exponents. I'm going to go over number 14 and 13 a little tiny bit. It's all review. But, hey, for number 12, perfect test question. If you ever have a negative exponent, you're going to move it to the opposite side. The bottominator becomes the topinator. The denominator becomes the numerator. Final answer is 4 squared. Mr. Maynard, my teacher says I can't leave it as 4 squared. You're right. You could write what 4 squared is as 8. No, not 4 times 2. What is 4 squared? 4 times 4. What's 4 times 4? 16. Yes. But for this test, you could leave it as exponents. 4 squared. or 16. You can write it that way if you want to. Your teacher would be okay with it. Okay. If you made it to this part, you're prepared for the test. If you made it to number 13 and 14, this is stuff that's coming a little bit. If it's not on your test, it's on a future one. All right, number 13 and 14. Here we go. Let me adjust myself, my seat. And let's do this last question. It's okay. Would you want this to be your bank account? No? So please, don't draw it as a positive graph. If it is a negative slope, make sure that it's going down. This thing is going at a starting value of 3, and the growth is going down by 2. So down by 2 means you're going down 2 and over 1. Down 2 and over 1 every day would look like that. Okay, for number 14, scale factor has us dividing 7.5 by 5. If that's new over old, you're going to get 7.5, the new divided by the old. And if you did it in this direction, you're going to get 7.5 divided by 5. What's 7.5 divided by 5? We get 1.5. That is our scale factor. That's what this question is asking for. It's a scale factor, but it's also asking what to do for x. So how do you solve for x? There's many ways to do it. You're like, Mr. Maynard, why do we solve for the scale factor? I don't know why we do that. Here's the thing. How much bigger is this triangle compared to that one? Yeah, the reason why we learned this is because every single side is simply growing by a multiplier of 1.5. So if you try to find out what your x value is, all you would need to do is take 6 and multiply it by 1.5. Now, what is 6 times 1.5? 9. And you're done. That's your scale factor from left to right. Now, you're probably saying, Mr. Maynard, I always cross multiply. Yes, you could cross multiply. Just do new side over old side is equal to new side over old side. As long as you do that correctly, you should get the same answer. I'll go ahead and zoom in here, okay? So, just to check our work here, cross multiply, we're going to get 5 times x, which is 5x, and 7.5 times 6, 7.5 times 6 happens to be 45. If you don't believe me, I'll show you. 7.5 times 6, 45. And now we're going to do a giant 1 to get x by itself. If I divide both sides by 5, I'll get my answer. Now, is this the same answer that we got before? 45 divided by 5 is 9. Yes, it is the same answer, which we can confirm it in 2 different ways. All right, so I hope that you found this video helpful. Of course, we went over a lot. We went over laws of exponents, scientific notation, division and multiplication, or operations of scientific notation, and a little bit more. So this is all stuff preparing you for our upcoming test, and I wish you good luck. Have a great rest of your day.